Hi, Assalamualaikum. For this session, we are going to continue with tutorial 13, chapter 28, problem 16. A photon is emitted when a hydrogen atom undergoes a transition from the n equals to 5 state to the n equals to 6 state. Calculate the wavelength, the frequency, and the energy in electron volts of the emitted photon. So this is the solution. Okay, this is the energy level or the orbit of the atom, or we can also say it is a state, energy state, energy level, or the orbit. They are the same thing. So N1, N2, N3, N4, and N5, and so on. N1 is actually the ground state. So the transition of energy is from energy level 5 to energy level 3. Initial energy level to the final energy level. This is the emitted photon with certain energy. Okay, because the transition is from the higher energy state to the low energy state, so that a photon will be released, or a photon will be emitted with certain frequency and wavelength. Okay, we can calculate the energy of the photon by using the equation EP equals to hc over lambda, or we can also calculate using the change of energy equals to final energy minus initial energy if we know the energy of each energy state. Okay, so question A, we need to calculate for the lambda or the wavelength. We can use the Rydberg equation. Okay, 1 over lambda equals to the Rydberg equation, the Rydberg constant times 1 over n final square minus 1 over n initial square. N is actually the energy level. Okay, so that lambda equals to 1 over r n initial square times n final square over n initial square minus n final square, where initial energy level equals to 5 and the final energy level equals to 3. So this is the value of the Rydberg constant, 1.097373 times 10 to the power of 7 times with and 1 equals to 5 square, 3 square over 5 square minus 3 square. Then you get the value for the wavelength. The wavelength is 1.281 times 10 to the power of negative 6 meter, or 1281 nanometer. This is in the infrared region. Okay, question B. You need to calculate for the frequency of the photon. Okay, the frequency of the emitted photon, you can use this general equation, C equals to F lambda. Okay, so frequency equals to C over lambda. C is actually the speed of light, where the value is 3 times 10 to the power of 8, and the wavelength is the value that we have calculated before. So the value for frequency is 2.34 times 10 to the power of 14 Hz. Okay, the third question is you need to find the energy of the photon emitted from the transition in electron volt. So energy of the photon equals to hc over lambda, where h is the Planck constant, 6.63 times 10 to the power of negative 34 times the speed of light 3 times 10 to the power of 8. So the lambda, then okay, you need to bear in mind that SI unit for energy is in joule, but the question requires you to find the energy in electron volt, so you need to convert joule to electron volt. Okay, so you need to know the equivalency between joule and the electron volt. 1 electron volt equals to 1.6 times 10 to the power of -19 joule. Okay, you need to put the unit joule at the back of -19 in the equivalency or in the equation. Okay, so once you convert the unit, and then the energy in electron volt is 0.970 electron volt. Okay, I hope you understand. Thanks for watching.